Okay, so I am right at the top of the sheet that got placed on your desk that is called Trig Functions Practice A. And these are just some additional problems to help you prepare for your quiz because I figured we could use that. And could you please take your formula sheets out as well? So you're going to want that, and you're going to want your formula sheet. Again, calculator needs to be in degrees. So if you borrowed one, I just want to make you aware of that. So let's pick one from each section here. So number one is to convert degrees, minutes, and seconds notation, referred to as DMS, into decimal degrees. Round your answer to the nearest thousandth. So number one, to type that in, you are going to go to your calculator. Again, I need to make sure this is in degrees, which it is. So I am going to type in 29 degrees. And where do we get the degree symbol from? What do you hit? Second, apps. Yep. So you're going to pick choice one. And then I'm going to go 45 minutes. So 45 minutes, again, that is second apps. And then I need to grab 26 seconds. And where am I going to find seconds? You guys remember? Yep, alpha plus sign. Again, that is the weird one. And then hit enter. That right there is what we refer to as decimal degree notation. So your first answer is 757. So any difficulty doing that? I didn't think so. Bless you. 29.757. Okay, so I'm gonna skip number 1B. You can go back and do that one just to get to you practice. Again, I'm gonna kind of do one of each section. So now going down to number 2. Now you are going to convert from decimal degrees to degree, minutes, and seconds notation. So what that means to do is you are going to type this in your calculator and you are going to convert this to DMS. So you are going to convert it to degree, minutes, and seconds notation. So you're going to hit second apps again for this one. So second apps. And you do not need to actually type that degree symbol right there. It should work fine without it. So did everybody get an answer of, I got 238 degrees. And I'm sorry, 36 degrees, 48 minutes. And I got 58.77. Did you guys get that in your calculators? So now what you're going to do is round it up. So the 8 is going to bump to a 9. So we have 236 degrees, 48 minutes, and 59 seconds. Okay. Any difficulty? Okay, so I'm going to skip 2B. I'm going to jump down to number 3. Convert degree measure to exact radian measure in rational forms in terms of time. So 200 degrees, you need to know that you are going to multiply by, so your formula is we're going to multiply by 180 over pi, and you are going to leave pi in your answer. So 200 pi over 180. Again, in the calculator, please do not type the pi. You're going to reduce this. So if I just get rid of the 0, I'm at 20 over 18 pi. And then I divide these by 2. So this would be 10, bless you, 9, and then pi. How do you feel with the first 3? Pretty good? Okay. So let's jump over and look at number 4 then. So anything I skipped, you definitely want to make sure you go back and look at homework just to make sure you're good and confident. All right, so next, I'm going to convert radian measure to degree measure in decimal degree form and DMS form. And you only need DMS if this answer becomes a decimal. Now I have 4 pi radians over 3. You don't do anything with the r. It just tells you you're in radians. So for our purpose, you can kind of ignore it. So what I'm going to do here is I am going to take out the pi and replace it with 180. Okay, so here's option number 1. You could just remember that pi is equivalent to 180. Or I'll give you the formula as well. So that's the first thing you can do. Or what you can do is multiply by 180 over pi, and you'll see that the pi's cancel. Okay. So what is 4 times 180 divided by 3? 240. Yep. So that is 240 decimal degrees, and there's no need to write that in DMS. So that one you can just stop. 4b will work out the same. Let's do 4c because it's different. What does 4c not have? The pi. Good. So I am going to go 1.75. Again, the radian exponent just means it's in radians. You don't do anything with that. And I am going to multiply this by 180. And I have to divide by pi because it does not cancel in this capacity. Okay, and that is just going to get typed in your calculator. And the answer comes back as, make sure you can get this, please, 100 point, I got 268. And that is in what we call decimal degree notation. That is one that you do have to go further with. So I'm going to go back to my calculator and just make sure you know how to do this. All right, so I am going to type in here 1.75 times 180 to get that number. So times 180, enter. And then I'm going to divide it by pi to bring me to the decimal degree answer. And then I'm going to take that answer and convert it to DMS. You don't need to show any work for that. You're just going to simply do this. Enter. So our answer is 100 degrees, 16 minutes and 3 seconds, because that does not round up. So just like that. Again, I don't really anticipate any trouble with that calculator. So that was decimal degree notation, and then your other would be 100 degrees, 16 minutes, and what did I say, 2 seconds? 3 seconds, and that is in DMS notation. Okay. So letter D would work out the same way. How do we feel on those? Pretty good? Okay, jump down to the next section then. So if each angle has a given measure and is in standard position, then what quadrant is the terminal side located in? So what do you suppose they should do with this first problem that's in radians? Yeah, convert it. So let's go -8 times 180. And divide that by 3. And can someone let me know, what does that work out to be? -480, thank you. Now, you can certainly work with negative angles if you'd like to, but if you prefer not to, add 360 to this, and then add 360, I believe, one more time to make this a positive angle instead. What happens when you add 720 onto this? Does anyone have that? 240? Okay. So this is 240 degrees. Personally, I think that's easier to work with because 240 is going to end up where? Yep, quadrant 3. So that would just be right here. Anytime it means standard position, it just means you're drawing one of those right triangles that we've been referring to all week. Quadrants need to be written as Roman numerals. Okay. Any problems on that section, or are those okay? I'm hoping they're okay. Yep. Yep. So that one's still going to be quadrant 2 because it's less than 180. Yep, good question. Flip your sheets. Number 6, let's do one of those quick. I'm watching my time, but I do want to give you a couple extra ones as well. Number 6, name a positive and a negative coterminal. What does coterminal mean you use? Plus and minus 360. That's literally all you have to do here. So you would go plus 360 and get one of these. So that'd be 300. And then you would subtract 360. That's it. So that would be negative 420 degrees. Don't worry about C, you may omit that one. That one you would just have to convert first, but it's the same idea. So I'm going to skip the rest of those, leave those for you just to practice. Number 7, find the reference angle. So 130 degrees. What quadrant? Good, quadrant 2. What's the rule in quadrant 2? What do I do? Beautiful, 180 minus 130. And by definition, a reference angle is an acute angle, so between 0 and 90 degrees, which that is. So you're good to go, 50. Again, with anything negative, you are welcome to do this and then go from there. Letter C, you would just change that into degrees instead. We good on those? Okay. So let me hop over to number 8. Number 8 is just a formula again, so I'm going to kind of leave this to you. This is just times pi over 180. I'll give you an answer. Again, just practice that if you think you need help with the calculator. That is 0.966. Okay. And then over to this last column. These are from your formula sheet, which is available to you tomorrow. All right. They're very straightforward. So this first one is just S equals R theta. The only thing that you have to remember is that your angle must be in radians. So if it's not, what do you have to do? Convert it. Which one here would need to be converted first? I think there's one somewhere. 9C, right? I'm going to do that one. S equals R theta. So therefore, subtended arc length is unknown. Remember that's when we talked about the pizza crust. Subtended arc length goes around the edge of the circle. My radius is 30 and theta would be pi over 180 with the conversion, reducing down to pi over 6. So pi over 6, and then you would simply type that in the calculator if it asks for nearest 10. I'm going to right now, for our purposes, just leave that as 5 pi. Same thing for D. And then the next formula that is also on your formula sheet pertains to area of a sector. Similar to subtended arc length formula, your angle must be in radians. Which one's not? Yep, this guy. That's it. So it's very formula based. The formula is available to you. You do not need to memorize it. So I'll just get this set up for you. And then I want to give you a couple additional questions as well. So squared, and then you would type in 82 pi over 180. Okay, so it's just literally calculations. That's it. And that one is going to come back as 38.1 if you've done that correct. Okay. Any questions on those? Okay. So if you want to finish those for homework later tonight, you're welcome to answer your posted for you. Find another place to write down a couple problems. Just again, because I want to make sure that you guys get these too. You need to be able to do this as well. I will give you as much as I can before that bell rings. So say I give you cos theta is equal to 15 over 17 in quadrant 1. I want you to find, I don't know, someone pick a trig function. Tan. I want you to find tan theta. What are you going to do? You're going to draw a picture of a triangle in standard position located in quadrant 1. Here's theta. Cosine represents adjacent over hypotenuse, indicating 15 and 17. How would I find the other leg? Yeah, Pythagorean theorem comes back as 8. Okay, let's Pythagorean theorem. And then how would you find tangent? You would do tangent is equal to opposite over adjacent, which in our case is 8 over 15, done. So that is just expressed as a ratio. All right, number 2. This one is a calculator question only. We haven't really done much with the calculator with reciprocals, but I need to show you. So I want you to find cosecant of 237.76 degrees to 4 decimal places. Again, there's really no work to show for this, but you do have to remember cosecant is the reciprocal of what? Sine. So what I have to do in the calculator is simply type in 1 divided by the sine of this. Okay, so go ahead and do that right now. Again, you do not need to input that degree symbol. And then that should be equivalent. I got negative 1.182. Everyone okay with that? That's it, just a reciprocal. See if I can squeeze one more last question in here. This is exact value. And it pretty much covers it. So find exact value of sine of 240 degrees. This is where you need to know your angles, okay? So 240 degrees is going to be in which quadrant? 3. So I draw a triangle in standard position located in quadrant 3. Next step is I do my reference angle. In quadrant 3, I do 240 minus 180, which is equivalent to the sine of 60, which should go off in your head as I need to know that number. So before I plug in that number, I'm going to do ASTC, because in quadrant 3, sine is negative. And now impress me, what is the sine of 60? Radical 3 over 2, look who studied. Awesome. Beautiful. Those 9 values are written in your notes, and that is why you need them. Okay, I'll squeeze one last question in, and then that covers actually exactly what I wanted to with you. And just make sure that you study those tonight, please, because I did give you an extra day. So lastly, number 4 is a tree question. I'm going to abbreviate. Tree is 50 meters high, tall. That sounds better. 50 meters tall. Casts a shadow of 20 feet. Find angle of elevation. So find angle of elevation. Again, just think of being at the mall and you're getting on an escalator. So here's my right triangle. Here's my angle of elevation. Shadows are located on the ground. And then your tree is 50 meters high. This is a trick question in which you're going to write one of your SOHCAHTOA functions. And which one is this? Tangent. So you're going to go tan theta equal to opposite over adjacent. And what do you need to use in the calculator when an angle is unknown? Second tan, yep, inverse tan. And I'm going to leave you at that because I am out of time. Do you feel better about those topics? Oh, it's not a 30, 60, 90, but it is a 90. Oh, this one? Because it's 60. Because it's because of the reference angle. Yep, good question. Do you feel better about this tomorrow? Is that helpful? Yeah, it does not matter. Oh, I see what I did. I'm sorry. That was my mistake. I should not have done that. Thank you. I thought you meant a label down here. So your homework is just prepare for your quiz, okay? If you want to finish these, which I'm going to encourage you to do, please do so. Answers are online for you.